Hi and welcome to my channel, Michael here. So the AC on my 2003 Jeep Grand Cherokee has failed again. A little bit of cold air comes out of the vent, but the fan motor doesn't blow, so the truck doesn't actually get cold, and that's a bit annoying in the middle of summer. Now, Jeep WJs actually have a pretty common problem with the fan motor failing. Problem is the fan motor controller, the connector into it, melts, and that causes the motor just not to run because no electricity is getting in. Problem is, I did that repair on my truck about 6 months ago, and it's either happened again or the fan motor controller itself is broken. So I'm going to try to take a look, see what I can do, see if I can get this thing fixed because I want to save the $100, and I'd like to have some cool air for the summer. Okay, so this is the fan controller from a 2003 Jeep Grand Cherokee. This unit has been repaired once before. Common failure on these is that the connector here, the input connector, actually melts, which is a little bit scary. One repair option is to solder some wires directly to the board, which is what I've done here, but the unit's failed again. So I'm going to try and repair this, see what I can do. Before I do that, I'll go through a little bit of a theory how this thing works. So essentially, this is your output to the fan motor. The fan motor needs a varying voltage in order to turn it to a variety of speeds, so you can set that speed to whatever you want, whatever's comfortable for you. There are two power input leads. There's a positive and a negative. Now, if you have a connector still on your unit, the colors of these wires are going to be different. I just used whatever wire I had. I put red there for positive, which is the standard, and green because I thought, well, green was close to ground, so I used green. But we basically have a positive and a negative lead right here. These are high current leads because your motor is a high current load. The motor's going to drain 10-15 amps, no problem. And in order to do that, there needs to be high power going into there, a high amount of current. This lead has a varying voltage from the climate control system. That voltage ranges from 0 volts to 14 volts, and it basically, through some magic in this unit here, takes the constant voltage that we have at these two leads and varies the output with a high current output to the motor. This control lead is a low current output, and the reason is all your control circuitry on the climate control system is all going to be capable of handling 100 milliamps, a couple hundred milliamps, something like that. Doesn't have the ability to dissipate enough energy, enough heat in order to control a motor. This unit is specifically designed to control a motor, and it's got, for example, a complete aluminum base here and a big heat sink, so that allows it to dissipate any heat generated in the process of varying this voltage here. First step is to pop it open. Get a flat screwdriver, and there's some tabs on the side here. You can pop them. And, oh, we got one. Oh, we lost our screwdriver. Okay, we've got another one here, and one here, and we got one here. Okay, lid comes off. So if we take a look at this, this is actually quite a simple circuit. It's not that complicated, which is a good thing because that means I probably can repair this. A lot of more modern cars are going to have much more complicated circuitry to deal with, and at that point you just have to replace it. If we look at the leads here coming in, you can see my repair, a little bit of shoddy tape there. I'm going to clean that up before I put this back together. But you can see on the board it's burnt out right there, so that's not looking good. This is where it was repaired before. I just soldered to the 3 pins of the connector there. I soldered directly to it. The board was burnt when I pulled it apart last time. Maybe it's failed on the other side, something like that. That's possible. The board itself, it looks like it's got a chip here. I can't see the numbers on it. I don't know what kind of chip it is. The good news is there's only 16 pins on this chip, so it's a pretty simple function chip. not doing a heck of a lot. I doubt it's got too much to it. We have our power input coming in through here. We've got a couple of coils and some capacitors, so we can see these are likely converting a noisy DC or a pulse DC into a constant DC power output to make a smooth current for this output motor. And in the center, we have connected to the this heat sink, which is really molded into the aluminum base there. We can see a couple of devices. One is a 3-pin device, so it's likely a MOSFET, basically a high power switching transistor. And then on the other side, it's hard to see, but it looks like we've got a 2-pin device, so that's going to be a diode, a high power diode. The diode is likely protecting this circuit from the transient spikes that occur when you fire up an inductive load. What can happen is the inductive load will generate a bit of electricity in basically a reverse polarity, and it'll burn out your circuit. So that explains why there's a big diode there. Other than that, it's pretty simple. It doesn't look like anything's smoked, other than this problem with the board. Let's pop off this heatsink and see what we got. Okay, that compound's making a mess. So yeah, there we have two high power devices, one 2-pin and one 3-pin. So those could theoretically be burnt out. It's possible. We'll have to see. Let's take the board off of this casing and see what we've got underneath, because I think the biggest suspect right now is that burnt out lead. Often, with electronics, you can take a look, you can see what's physically damaged, and that will be the source of your problems. Not always the case, but it often occurs that it is the case. So let's get this apart. There's 2 Torx screws on this unit. I have no idea why Jeep insists on using Torx everywhere, but they do. If you don't have Torx bits now and you own a Jeep, well, invest, because you're going to need them. Okay, let's pop this board up. So we can see the back casing here. It's basically a solid block of aluminum. Reason being is there's a lot of heat being generated as you're getting rid of the voltage from the motor, and that's going into this block of aluminum. So it actually may be a little bit too small. Who knows? At the back here, let's take a look at our connections. So yeah, if you can see, this is that positive lead that was burnt. It looks pretty nasty. There definitely could be an issue there. This is the control lead. It also appears to be in bad shape. Seems to be, almost like the solder joint's failing there. So let's get out the multimeter and see what it says. So I'm just on the resistance setting, and I'm going to go from that nasty looking lead there. See if I can do this here. And I'll find the closest connection point from this lead somewhere I can test. Okay, so it looks like right here. And nope, the connection is actually good there, so that's not the problem. Okay, let's try the control lead. So control lead goes here, goes around, it's going around in a circle, and this is a nice spot to test it. And nope, this lead's good too. So it's actually not those, although I will repair these. I'll reflow the solder on that just so it stays, but that's not the problem. So maybe it's one of those transistors or that diode that's failed, or that chip that's failed. Let's just do a bit more of a visual inspection, see what we got. Looking on this side, looks good, looks good, looks good. Here I've got some surface mount components. There's a little transistor sitting there, resistors and whatnot, capacitors. There's the bottom of the chip. All those connections are good. Nothing's smoked, nothing's burnt out. Everything looks good. You can see these meaty connectors here. This is your, that's your voltage output right there. No, that's going to the voltage output. Sorry, voltage output is right there. So that's your positive lead. So you can see they're nice and big connectors going there. And oh, hey, look at that. See this guy here? That is not connected to anything. The solder, there's just no solder there. Let's take a look here. What's that connected to? Okay, so that on this side of the board is connected to the center lead of the big MOSFET. So that's my problem. I can almost guarantee you there's no way this circuit will work if that MOSFET is not correctly soldered in. So I'm going to bet you that is my problem. So let's solder that up and see what happens. Okay, so here we are ready to solder this to fix this unit. Soldering iron's all heated up, and I got the board here, and I'm just gonna fix that one connection right in there. I want to heat the connection and the board. I don't want to melt that solder on the iron itself. Let's just get that there. Ooh, well, hey, not perfect. There we go. I think we're pretty good. And I'm going to heat this one up here and repair that connection. Good. And then let's get the control lead done here. Perfect. Okay, so I think we are in much better shape now. Let's just flow that one more time. Perfect. We got a good solid connection. Let's try to apply some power to this and see if we can make it do anything. So this is the view from under the passenger side dash where the fan control module is located. Like I mentioned before, I already replaced the power connector which had melted, so that's why there are 3 jumper leads already wired in. From the factory, the red and black are the positive and negative leads, and the yellow is the control lead. So before I test the control module, I'm going to connect my oscilloscope to the control lead and show you what the waveforms look like. So I've connected the oscilloscope up, and I've got it sitting on my driver's side seat right there. Bit of an old oscilloscope, and you can see there's a waveform on there right now, which is basically the fan running at mid-level. I'm going to turn it down, and it goes to 0 volts, and then I'm going to turn it back up again, and you'll see that pulsating waveform as it's up. Okay, let's fire this thing up, see what we get. Come on, baby, work. Fans off. Hey, look at that. We've got cold air. Nice.